Hello everyone, and welcome to another episode of Interstigation. And in today's episode of Interstigation, we'll go over 2024 AMC 8, as you can see on the screen over here. It's been a long time since I posted a video, but I have not forgotten about 2023 AMC 10 yet, and I will be posting those videos very, very soon. But for the time being, let's take a look at AMC 8. Let's get started with question number 1. Question number 1 says, what is the ones digit of this expression? And in order to know the ones digit, we only need to care about the ones digit of each of these terms. Why? Because let's think, if we have 7 plus 4, 11. If you have 17 plus 4, then the tens digit over here merely acts as the tens digit in the result as well. So that becomes 21. That is exactly the same ones digit if we started with the same ones digit. Therefore, we just say, 2 minus 2, minus 2, minus 2, minus 2, minus 2. And if this seems a little hard to do, maybe because we don't care about what tens digit is, we can add a 1, no problem in the first one. So we can see, this is just going to be 12 minus 10, or 2, which is our answer choice B over here. All right, let's move on to number 2. Number 2 asks us, what is the value of the expression in the decimal form of 44 over 11, that's just 4. 110 over 44, we can factor out an 11, so that becomes a 10 over 4. And 44 over 1100, we can get rid of an 11 as well, so that becomes 4 over 100. And this is just 4 plus 10 over 4, which is 2.5, and 4 over 100 is 0.04. And if we add these up, we get 6.54 as our final answer, or answer choice C. All right, let's take a look at the next question, which says, 4 squares of side lengths 4, 7, 9, and 10 are arranged in increasing size order so that their left edges and bottom edges align. The squares alternate in color pattern white, gray, respectively. What is the area of the visible gray region in square units? So in order to find the area of visible gray region, we can take a look at these two regions separately. So I've shaded in black and blue respectively. In order to find the black area, we just have to do the bigger gray square minus the smaller white square, which is 7 squared minus 4 squared, or that gives us 33. Make sure you don't make a mistake on that. That would be very sad to do. Blue region is going to be 10 squared minus 9 squared, which is 100 minus 81, which is 19. So we just have to add them up. Now that gives us 52, or answer choice E. Cool. Let's take a look at number 4. Number 4 says, when Yoonji added all integers from 1 to 9, she mistakenly left out a number. Her incorrect sum turns out to be a square number. What number did Yoonji leave out? So if we did add up all the numbers from 1 to 9, that would give us 45. And the biggest square number that is less than 45 is 36, because that's 6 squared, and one bigger, 7 squared, is 49. Therefore, the square number has to be 36, because if it's smaller, then clearly we cannot have just left out a single number. Maybe we left out multiple numbers. Instead, it is 45. So now, because we have 36, so the number that she left out is going to be 9. If we don't add 9, then 1 plus 2 all the way through 8 is going to be 36. All right, let's take a look at number 5. Number 5 says, Alia rolls 2 standard 6-sided die. She notices that the product of the two numbers rolled is a multiple of 6. Which of the following integers cannot be the sum of the two numbers? So it is a multiple of 6, so we can think, well, if it cannot be the sum of two numbers, let's say if one of the side is a 6 and we don't know the other one, then their product has to be a multiple of 6 because we're multiplying a 6 with another number 1 through 6, another integer. Therefore, we don't really care about the next one. It could be 1 or 2 or 3, and all of these are eliminated because if it's 1, 2, or 3, they are definitely a multiple of 6. Now, note that we cannot have a 0 because 6-sided die doesn't have a 0. Maybe we can have a 5. Yes, indeed, 2 times 3 is going to give you 6, which is a multiple of 6. Therefore, 5 is also possible. Then our only answer left is going to be 6, which is indeed impossible for us to achieve. All right, let's take a look at number 6. Number 6 says, Sergey skated around an ice rink, gliding along different paths. The gray lines in the figures below show 4 of the paths labeled P, Q, R, and S. What is the sorted order of the 4 paths from the shortest to the longest? All right, we can take a look at this diagram. And this diagram, path P is just the standard one that goes all around, and path, let's compare that to path R first. Path R compared to path P goes in a circular arc, while path R just cuts into it. When you think about, let's say, cutting when you're walking, cutting through the grass, for example, you don't want to walk all the way here. Maybe you will cut around here. This means that this cut length is going to be shorter than the original length. So R is less than P. The length of R is less than the length of P. And now let's compare P and S. P and S gives us, well, these are the difference for P and S. And the difference is going to be that S goes across like this, and clearly the blue lines are longer than the black lines. Therefore, we would have P is less than S in terms of length. And now, lastly, we can take a look at comparison between Q and S. And the comparison between Q and S, we can draw in the S on top of Q, looks like this, and path Q looks like this. Now, here, when we look at the entire thing, it might be overwhelming. So because we have 2 zigzags for each, we just can look at one of them and compare the length of one of them. So we compare the length of this versus the length of this red segment. And if you don't see which one is longer, maybe we can reflect this second half to the other side. So we turn this into the other side. Now we can see that, perhaps it helps to draw out a right triangle here. This length goes further away, so it has a longer distance. So S is less than Q in terms of distance. Therefore, the sorted order is going to be R, P, S, Q, which is answer choice D over here. All right, let's take a look at number 7. Number 7 says, a 3x7 triangle is covered without overlap by 3 shapes of tiles, 2x2, 1x4, and 1x1 shown below. What is the minimum number of 1x1 tiles used? So we want to utilize the 2x2 and 1x4 tiles as best as possible. Now, if we just put 2x2 tiles like this and 1x4 tile like this, we will have to use 5 1x1 tiles. So, and we cannot put 1x4 tiles, say, in vertically. 1x4 tiles can only be used horizontally. So let's think about how we can optimize the number of 1x4 tiles we can use, or optimize the number of 2x2 and 1x4 tiles we can use. Now, one observation you can make is that if we don't consider this 1x1 tile, then this 2x2 and 1x4 each occupies 4 spots, and 3x7 triangle has 21 smaller squares. This means that we would have to have, I just drew a construction for you that it is possible for us to have 1, 2, 3, 4 of the 4 square tiles. This means that we have a 16 is possible, and there are 21 in total, so we need 5 1x1s. Now, if we put another either 2x2 or 1x4 in, then we have to have occupied 20 different spots. This means that only one is left. So that eliminates options B, C, and D. And maybe if you just got here and you're not sure if 1 is possible, here is perhaps a 50-50 split that you can guess. Maybe don't guess 2, 3, or 4. So to truly prove that 1 is not possible, we can color in the cells like this. Just every other column is colored black. So now we have 12 total black cells and 9 total white cells. Now, if we consider any 2x2 tile that we put on this grid, it is going to occupy 2 black and 2 white. If we consider any 1x4 we put on this grid, and remember we can only put it horizontally, it is going to be, again, 2 black and 2 white. Therefore, regardless of how many 2x2 or 1x4 cells we put in, the number of black and white cells is going to be the same. And because there are 3 more black cells, those 3 black cells are inevitably going to give 3 1x1. So we need at least 3 1x1s, therefore 1 is impossible, and thus our answer is going to be E5. All right, let's move on to number 8. Number 8 says, on Monday, Tay has $2. Every day, he either gains $3 or doubles the amount of money he had on the previous day. How many different dollar amounts could Tay have on Thursday, 3 days later? So we have on Monday $2, and every day he either gains $3 or double the amount of money. The first day, or I guess the Tuesday, 1 day later, we could either double and get $2 or gain $3. So that means we could have either $4 or $5. Now we could either double the amount of money that gives you $8, or we could have plus 3 that gives you $7. Plus 3 for 5 gives you $8. That is a repeat, so do not write that down again. And we could have a double, which is $10. Now for $8 we could have plus 3, which is 11. Double is 16. For 7 we could have plus 3, which is 10. Double is 14. Plus 3 is 13, and doubling gives 20. All of these are distinct. We can count 1, 2, 3, 4, 5, 6. There are 6 different possibilities. Therefore, let me just move this to the side. Our answer is going to be D6. All right, let's take a look at number 9. Number 9 says, all the marbles in Marius' collection are red, green, and blue. Mary has half as many red marbles as green marbles and twice as many blue marbles as green marbles. So let's say if the number of red marbles is x, then the number of green marbles is 2x, and twice as many blue marbles as green marbles, so the number of blue marbles is 4x. And we want the total number. The total number is x plus 2x plus 4x, which is going to be 7x, and it has to be divisible by 7, which the only number divisible by 7 here is going to be 28. Move on to number 10. Number 10 says, in January of 1980, the Mauna Loa observation recorded carbon dioxide levels of 338 parts per million. Over the years, the average CO2 reading has increased by about 1.515 ppm each year. What is the expected CO2 level in ppm in January 2030? We want to round your answers to the nearest integer. So we could draw a graph if you don't intuitively get what it is asking. In 1980, it is at 338 ppm. And sometime we want to find in 2030 how many ppm is that. And we are given that every year it increases by 1.515 ppm per year. So YR stands for year. And it is going to be 50 years from 1980 to 2030. So 50 years. That is going to be, you multiply this by 50, or you can multiply this by 100, so that's 151.5, and then divide by 2, which is going to give you 75.75 ppm. And that we have to add to 338. Now, because it asks us to round to the nearest integer, so we can just round in this step and say, okay, we have 338 ppm plus, now it's basically 76 ppm, which if we add that up, we get 414 ppm, which is answer choice B over here. All right. Number 11. Number 11 says the coordinates of ABC are 5, 7, 11, 7, and 3y with y is greater than 7. The area of ABC is 12. We want to find the value of y. So we want to find the value of y over here. And the y greater than 7 just merely means that the point C is going to be above line AB. And the area of it is 12. We know the base is going to be length 6. And if we draw a height that is going to be height, then we know that the area of a triangle is 1/2 base times height, which is equal to 12. So the height is going to be equal to 4. And therefore, height is going to be 4. Let's replace that with 4. And so we are already on y level 7. And if we add 4 more, we are going to be on y level 11. So point C is going to be 311, or our answer is going to be D. Let's move on to number 12. Number 12 says, Rohan keeps a total of 90 guppies in 4 fish tanks. There is 1 more guppy in the second tank than the first tank. There are 2 more in the third tank than the second tank. There are 3 more in the fourth tank than the third tank. How many guppies are in the fourth? So we know that, let's say the first tank had X guppies. Then the second tank will have X plus 1 because that's 1 more. And the second tank has X plus 1. So the third tank has X plus 1 plus 2, which is X plus 3. And there are 3 more guppies in the fourth than the third. So that will be X plus 3 plus 3, so that's x plus 6. Then we just add them up to get x plus 1 plus x plus 3 plus x plus 6 is equal to 90. On the left hand side, just do this carefully, don't get it wrong. 4x plus 10 is 90, or 4x is 80, which gives x is equal to 20. And therefore, we would have that, how many guppies are in the fourth tank, which is x plus 6, or 20 plus 6, or 26, which is our answer choice E. Number 13 says, Buzz Bunny is hopping up and down a set of stairs one step at a time. In how many ways can Buzz start on the ground, make a sequence of 6 hops, and end up on the ground? For example, let's draw it like this. So let's make it so that on the horizontal axis here, we have the number of ups, and the vertical axis, we have the number of downs. And what does it mean for us to not have go down below the ground level? That means we cannot have more downs than ups at any given point. Therefore, these points we cannot reach at all. Therefore, now we have basically just transformed this stair problem into a problem where we basically says, oh, we start from 0, 0 and we want to go to 3, 3. How many ways are there to do so when only staying in this lower bottom right triangle? So we can say, to start with, there's exactly one way. Now we have exactly one way all the way to the right. And for every cell, let's say for this cell right here, we have 0 ways to come from the left and 1 way to come up. So that is going to be 1 way in total. So for each point, we are just going to add up the number of ways that we can come from the left or we can come from below. Because the only ways we can get to 2 ups and 1 down is if the step before is 2 ups and 0 down, or 1 up and 1 down. Therefore, we can just add up the numbers like this, and we see it is going to be our final result 5, which is our answer choice B. And this problem is not too hard to solve if you just list out all the possibilities, because there are only 5 possibilities at the end of the day. But if it says suddenly, oh, we want 8 hops, then you can just extend this grid by 1, because now it will be a 4x4 grid, and you can solve this problem pretty easily instead of you having to list out everything again. And this is a more scalable method. All right, let's take a look at the next question. The next question says, the one-way routes connecting towns A, M, C, X, Y, Z are shown in the figure below, not drawn to scale. The distance in kilometers along each route are marked. Traveling along these roads, what is the shortest distance from A to Z in kilometers? So here is A and here is Z. Don't get fooled by the diagram, because there are various ways that we can travel to each of these cities. What is a good way for us to keep track of the shortest distance is that, okay, we know ourselves this, we start at A, and the shortest distance from A to A, let's just say the labels are the shortest distance from A to that town. And why that helps us is that we don't have to go back to all the way in the beginning to try every single route. Now, at the very end, we just take the minimum from every path from the point so that we can better understand, and we don't have to go back to town A for every single thing we try. So for example, for town X, clearly the shortest distance is 5. And for town M, we can either go here in 8, or we can go from X, that is in 2. But remember, to get to point X, it already takes 5 kilometers, so that is going to be 7 kilometers in total. And 7 and 8, 7 is smaller, so we keep a 7 instead. So here for town Y, we could either have 10, which would give you a sum of 15, or 6, which will give you a sum of 17. So the shortest distance to Y is 13. To C, the shortest distance is either 7 plus 14 or 13 plus 5. So that's 18. Now to Z, the shortest distance is either 30, 28, or 7 plus 25, that's 32. So the shortest distance is 28, which is answer choice A. Now you might get lucky if you just did this route the first time through, which is actually this route over here the first time through. But if you didn't get lucky, you might be doubting yourself whether or not this is the shortest distance, but just keeping track at every single town, the shortest distance from A, we are confident that at the end this is the shortest distance. All right, let's go ahead and take a look at number 15. Number 15 says, let the letters F, L, Y, B, U, G represent distinct digits. Suppose FLY is the greatest number that satisfies the equation 8 times FLY is equal to BUG. What is the value of FLY plus BUG? So this is a 6-digit number, and we have that 8 times FLY, you can factor this out to be 8 times 1001 times FLY as a number, which is 1001 times BUG as a number. We can cancel out the 1001 on both sides, so we get 8 times FLY is equal to BUG. We want to find the greatest number FLY. And now we have that BUG is a 3-digit number, and therefore 8 times 125 is 1,000, which is too big. Now let's try something smaller. 8 times 124, that is going to be 1,000, my bad. 992. That doesn't work because we're told that they are distinct digits. 8 times 123 is 984, and 1, 2, 3, 4, 8, 9 are indeed distinct digits. So the answer is just 123 plus 984, which is going to be, this is easier if you calculate this as 1,000 plus now 123 minus 16. Just a suggestion, because 123 minus 16 is easier to deal with. Just in my opinion, 1107, or answer choice C. All right, let's take a look at number 16. Number 16 says, Min enters the numbers 1 through 81 into the cells 9 by 9 grid in some order. She calculates the products in each row and column. What is the least number of rows and columns that could have a product divisible by 3? So we want to find the least number of rows and products that are divisible by 3. All the numbers that are divisible by 3 are 3, 6, 9, 12, all the way to 81. So there are 27 such numbers. And in those 27 such numbers, we need to have how many? Right. If there is, let's say, a column or a row that has this one of these numbers, let's say 3, then the product in this column is going to be divisible by 3 regardless of the other numbers you put in. Therefore, we kind of have to find a way where we can cram all of these numbers in as little number of rows as possible. And there are 27 different numbers. There are two different ways we can quote unquote cram all those numbers. We could put all of these numbers in, let's say, 3 rows. Then this means that every column is going to be divisible by 3. That gives us 12. Maybe we can do better. Let's think. 27, we can factor this to be 9 times 3. Is there another way that we can cram those numbers such that this product is 3 in less columns or rows? So maybe we only have 3 rows right now. Maybe we could sacrifice more rows in order to compensate for that. How about let's try 4 rows? If we have 4 rows, then each row we need to sacrifice 7 columns, because 4 times 7, let me just erase this column here for clarity. If we have a 4 by 7 rectangle, then we could fit all of the numbers in here, and only these 4 columns and 7 columns and 4 rows are going to be divisible by 3. That is 11. How about we could have 5 times 6? Well, 5 times 6, that's 30. 5 times 5 is not enough numbers. So the best we could do is actually just 11, because if we reduce more, if we have a sum of 10, then 5 times 5 is the best we can do, which is 25, and that is less than 27. Therefore, the answer is going to be D. All right, number 17. Number 17 says, a chess king is said to attack all squares one step away from it, horizontally, vertically, or diagonally. For instance, a king on the center square of a 3 by 3 grid attacks all 8 other squares, as shown below. Suppose a white king and a black king are placed on different squares of 3 by 3 grid so that they do not attack each other. In how many ways can this be done? So, if there is a king that is in the middle, then there is no way to put another king down. If there is no king such that it is in the middle, then perhaps, let me just rule that out. Say there is no king in the middle, then we could do casework on where the king is. Let's say if the king is in the corner, if one of the king is in the corner, that's 4 different ways, and the king would attack these 3 positions. So we can put the white king any of these 5 positions. White is not really drawable because the background is white, so I will use blue instead. So these 5 positions. So that would be 4 times 5, because there are 4 corners, 20 different ways. And now, if we put the king instead in one of the edges, let's say here, then it would attack here, 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 here. Therefore, we would have these 3 open. That is, we have 4 times 3, which is 12 different ways. Therefore, we would have E, or 32 different ways in total for us to get this done, where the black king and the white king doesn't attack each other. All right, number 18. Number 18 says, 3 concentric circles are centered at O with radii 1, 2, and 3. So basically, this segment is trisected. Both point P and C lie on the biggest circle. The region between 2 smaller circles is shaded, as is the portion of the region between the larger circle bounded by the central angle BOC, as shown in the figure below. Suppose the shaded and unshaded regions are equal in area. What is the measure of BOC in degrees? So we want to find the measure of BOC. And the whole area is just going to be pi times 3 squared. So that's 9 pi. The area of the whole thing, let me just write that more legibly. Area of the whole thing is going to be 9 pi. And so the area of the shaded region is going to be 4.5 pi. Right, shaded is going to be 9/2 pi. Same thing. All right, so regardless what BOC is, we can figure out what this area is, because that doesn't depend on BOC. This area is going to be the area of the black shaded one is going to be 4 pi, which is the middle circle, minus the pi inside, so that's 3 pi. So the area of the blue shaded is going to be 9/2 pi minus 3 pi, or 3/2 pi. Now, the blue region can be found another way. Find the proportion of which the blue is with respect to the whole big ring, and that will be angle BOC over 360 degrees, which is the whole thing, and that multiplied by the area of the ring, which is 9 pi minus 4 pi. So we have 1/72 degrees angle BOC times pi. And this is equal to 3/2 pi. And therefore, we could cancel out a pi and multiply the 72 degrees on the right. That cancel out to 36. Therefore, angle BOC is going to be 108 degrees, or answer choice A. I will use black. All right, number 19. Number 19 says, Jordan owns 15 pairs of sneakers. 3/5 of the pairs are red and the rest are white. 2/3 of the pairs are high top and the rest are low top. The red high top sneakers make up a fraction of the collection. What is the least possible value of this fraction? We can use a two-way table to organize this information better. So we could have red, white, total. We have high top or low top or total. So the total of total is going to be 15. 2/3 of the pairs are 3/5 of the pairs are red. Therefore, there are 9 red ones and 6 white ones. 2/3 of the pairs are high top and the rest are low top. 2/3 is going to be 10 and the low top is going to be 5. The red high top sneakers make up a fraction of the collection. The red high top. So we want to find the least possible value of this fraction that corresponds to the least number of red high tops. How do we do that? We have the least number here, so we have the highest numbers here and here. So the least number here, I will use a circle to represent. We want the least number here. So instead of doing, let's say, 5, we could have, what if this is 0? Then we could have this is 6, we could have this is 5, and therefore the red high top is going to be 4. Note that we cannot have this to be any lower, because if this is any lower, let's say if this is 3, then this number is going to be negative, and that doesn't work at all. Therefore, the fraction is 4/15, unsimplifiable, so our answer is C. Cool. Let's go ahead and take a look at number 20. Number 20 says, any 3 vertices of the cube PQR, ST, U, V, W shown in the figure below can be connected to form a triangle. So let's say these 3 figures can be connected to form a triangle. For example, vertices PQR can be connected to form triangle PQR. Cool. How many of these triangles are equilateral and contain P as a vertex? So we know that it contains P as a vertex, and we want it to be equilateral. Connecting to any 2 points in this cube, let's just say the cube has side length 1, so that it is easier for us to distinguish. And we have 3 different types of length when connecting to the different vertices. When connecting to F, Q, and W, the length is going to be 1. When connecting to R, V, let me use a different color, R, V, or T, the length is going to be square root of 2 by Pythagorean theorem. Or if we were to connect to U, the length, oops, that is way too light. The length is going to be square root of 3. And clearly we cannot have a square root of 3 because that does not work as the side length. And how about we could have 1, right? But no, because if we have a 1, let's say, regardless of which ones we choose, they're symmetrical. So let's just take a look at this one. Then the other length is square root of 2. So that doesn't work. So the only option we're left with is going to be utilizing 2 of these square root of 2 sides. Let me just erase everything else. So we could have a situation where we look at QR and PV, PR and PV. Then the other side is going to be RV. That is a legal triangle. We could have, let's say, connect PT and PR. That is going to give us this one. And this one, remember that TR is also square root of 2 side length. So this actually is an equilateral triangle, even though it might not look like it. And the last one, we could connect PT and PV. These two also form an equilateral triangle. This one does not look like it at all either, but it actually is an equilateral triangle. You can use Pythagorean theorem to verify that each side length is square root of 2. So there are 3 different equilateral triangles that you can choose. And that gives us the answer choice D. All right, moving on to number 21. Number 21 says, a group of frogs called an army is living in a tree. A frog turns green when in the shade and turns yellow when in the sun. So when it's in the shade, very, very bad drawing, but it is green when it's in the shade. All right, the sun, so it is yellow when it is in the sun. Initially, the ratio of green to yellow dogs is 3 to 1. So this is 3, this is 1. Then 3 dogs move to the sunny side and 5 yellow dogs move to the shady side. Now the ratio is 4 to 1. What is the difference between the number of green frogs and the number of yellow frogs now? So now we can, let's say initially we have X on the yellow side and 3X on the green side. Then after that, we have 3x minus 3 plus 5, or 3x plus 2 on the left, and x minus 2 on the right. And this is a 4 to 1 ratio, so 3x plus 2 is 4 times x minus 2, or 4x minus 8 is 3x plus 2, or that x is equal to 10. Now, the answer is, what is the difference between the number of green and yellow dogs now? And we have 32 green frogs and 8 yellow frogs. So the difference is going to be E24. All right, let's move on to the next one. Number 22 says, a roll of tape is 4 inches in diameter and is wrapped around a ring that is 2 inches in diameter. A cross-section of the tape is shown in the figure below. The tape is 0.015 inches thick. If the tape is completely unrolled, approximately how long would it be? Round your answer to the nearest 100 inches. So what we are looking at here is that this thickness is 0.015 inches, and we want to find, if the tape is completely unrolled, approximately how long would it be? And if it is completely unrolled, let me draw it over here. Let's think about it like this. And this is basically a rectangle when we look at it from this angle of width 0.015 inches, and the length is what we want to find. Let's call that L. And now we can find the area of this region, and this region is going to be, the area is 0.015 inches times L. That is one way to find the area. The other way to find the area is to find the area of this ring, which is going to be pi times, remember, 2 inches squared, because the radius is 2 inches and the diameter is 4 inches. Therefore, minus pi times 1 inch squared, which is 3 pi inches squared. So that's equal to 3 pi inches squared. Now we just have to solve for L. L is going to be 3 divided by 3 pi divided by 0.015 inch, which we can take a look over here. That is around 3 times 3.14. That's probably enough digits. Divided by 0.015, moving the decimal point right 3 times, that gives us 15, and we need to multiply by 1,000. About that many inches, and we can cancel out a 5 over here, and we can cancel out the rest over here. So we have pi basically times 200 inches, which is going to be somewhat around 600 inches, because it will be something like 628 inches-ish. So that's our answer choice B. All right, number 23. Number 23 says, Rodrigo has a very large sheet of graph paper. First, he draws a line segment connecting the point 04 to point 20. So this is like 04 to point 20. And colors the 4 cells whose interiors intersect the segment. So graph paper looks like this, right? 1, 2, 3, 4, 1, 2. Graph papers look like this. And he drew a line segment from 04 to 20. And colors the 4 cells, that is these 4 cells. Let me just get a more legible color. These 4 cells, even though I have not drawn them to scale, you can get the idea. Whose interiors intersect the segment as shown below. Next, Rodrigo draws a line segment connecting point 2,000, 3,000 to the point 5,000, 8,000. How many cells will he color this time? So this looks like a very, very big number. But don't worry, let's try to look at these points. These points, oh my god, there are like thousands behind all of them. Maybe let's just ignore it for now. And let's see what happens if we draw it from 2, 3 to 5, 8. So let's draw cells over here. So 2, 3 is this point, and 5, 8, 3, 4, 5. So this is 5, and 8 is this point. We just extend it over here. So this is 8. So that's 5, 8. Nope. This point is 5, 8. So that is, we have 1, 2, 3, 4, 5 up and 3 to the right. Now, if we draw it, that will be line like this. And through a line like this, it probably doesn't help that I am freehanding it, but we can see that over here we have drawn through this point, this cell, this cell, this cell, this cell, this cell, and this cell. So we have drawn through all those cells. That is 1, 2, 3, 4, 5, 6, 7 different cells. So we have drawn through 7 cells. Now we think about, oh, what happens when we do this? When we scale this up by 1,000. Now this is basically you repeat the same ones, but except that in each of these cells, you repeat. You can think of this as, let's say, let me just erase this part so I have some space to write. Let's just say this is 2,000, 3,000. Then over here, we would be at 2003. Oops, that's not 3003. 2003 and 3005. We just have to repeat this 999 more times for us to get to our final destination of 5,000, 8,000. Therefore, it is basically the same but repeated 999 times. And this we have 7 cells if we do it once, and we do it 1,000 times. So we get 7,000 cells. That is answer choice C. All right, moving on to number 24. Number 24 says, Jean has made a piece of stained glass art in the shape of 2 mountains, as shown in the figure below. One mountain peak is 8 feet high, while the other is 12 feet high. Each peak forms a 90-degree angle, and the straight sides form a 45-degree angle from the ground, with the ground. The artwork has an area of 183 square feet. The sides of the mountains meet at an intersection point near the center of the artwork, h feet above the ground. What is the value of h? So we can extend this part so that it reaches the bottom. And if it reaches the bottom, we can see, oh, this is 8, this is 8. So we have that this side is 8 root 2. Similarly, this side is 12 root 2 if you just do Pythagorean theorem. Now, what do you do next? You might think, oh, what if, let's just calculate the area of this triangle first. And the area of this triangle is calculatable. That is 8 root 2, we use an actual pen, 8 root 2 times 8 root 2 over 2, which is 64. And what about the area of this? The area of this is going to be, similarly, 12 root 2 times 12 root 2 over 2, which is 144. Now the actual area is 183, but we overcounted the middle part. So this middle part, let me use a new color instead. Let's say yellow. Let me actually try to carefully draw this time. And this area is going to be, right, 64 plus 144 minus 183, which is 208 minus 183, so that's 25. And therefore, if this area is 25, and if this is h, then this is h, and this is h, because everything is 45 degree, 45 degree, 90 degree, so they're all right isosceles triangles. And therefore, we would have 2h times h over 2 is equal to 25, or that h is equal to 5, which is answer choice B. All right, number 25. Number 25 says, a small airplane has 4 rows of seats with 3 seats in each row. 8 passengers have boarded the plane and are distributed randomly among the seats. So we don't care where exactly they are, but they are just distributed randomly. A married couple is next to board. What is the probability that there will be 2 adjacent seats in the same row for the couple? So apparently this airline does not have pre-assigned seats, but that's besides the point. Let's take a look. So for those to have random seats, instead of considering the seats already taken, perhaps it is easier for us to consider the seats that have not been taken. So 8 seats have already been taken, so 4 seats have not been taken. Therefore, we have 12 choose 4, which gives us 12 times 11 times 9 times 10 times 9 over 4 factorial, which in this case, you don't have to calculate it out, but we have here, it's just equal to 11 times 9 times 5. I know this is 495, but don't calculate it out. Maybe because we are working with probability, maybe leaving it in a factored form will help us later. Now let's take a look. The 4 empty seats may be 3, 1. So 3, 1, and the other 2 have 0 empty seats. We could also have 2, 2, and the other will have 0 empty seats. Or we could have 2, 1, 1, 0, or we have 1, 1, 1, 1. In each of these 4 cases, let's consider 1, 1, 1, 1 first. If we have the last case, then that means each row has exactly 1 seat. That doesn't work out very well, does it? Because if each row has exactly 1 seat, then regardless, this married couple cannot have 2 seats next to each other. So 0 cases for this. How about 2, 1, 1, 0? We now here the row with 2 must be next to each other. So that's 2 different choices. That means here, here, or here, here. So that's 2 different choices. So that's 2. And the ones, we have 3 different choices because the 1 can be in any of these 3 different seats times 3. We have 2 1, so 3 squared. And we have a 0 at the end. That 0, that just is 1. Now we have to choose exactly which row has 2 seats. There are 4 ways to choose exactly which row has 2 seats, and there is exactly 3 ways to choose exactly which 2 rows have 1 seat. This is because, let's think about, one of the rows have been taken, so essentially we're now working with 3 rows. Now we have to choose 2 rows that has 1 seat. That is equivalent of choosing 1 row that has no seats. So therefore, we're just choosing 1 out of 3. That is 3 choose 1. That is also the reason why 3 choose 1 is the same as 3 choose 2, if you have not realized. But here is this case, and this is 2 times 9 times 4, which is 72. Different cases over here. All right. The next one we would have, it is times 4 times 3. I forgot to multiply the last 3. So this is 216 different cases over here. And if we have 2, 2, then think about it. First of all, let's take care of the choosing the rows first. So choose 2 rows, that's 4 choose 2, or 6 different methods to choose 2 rows to have 2 seats. And in those 2 rows, we could either have exactly one row that has 2 consecutive seats. So that is 2 different choices because one of the rows have to be 2 consecutive. The other row has to be not consecutive. That's 2 choices if it's that way, or 2 choices if I flip it. So that will be 1 over here and 2 over here. So that's another 2. And if both of these have consecutive choices, so that's 2 choices on top, 2 choices on the bottom, that's plus another 4 times 6, that is 8 times 6 or 48. If we have 3, 1, 0, 0, then regardless, because we have a row of 3, then this row of 3 will definitely have a consecutive 2 adjacent seats. So that works out. We just have to choose the rows. Now, we choose row. There are 4 ways for us to choose the row with 3 seats and 3 ways for us to choose the row with 1 seat. And in this row with 1 seat, there are 3 different options where this seat can be. So that's another times 3. So this is 36 different choices. Now, if we add them up, 36 plus 48 plus 216, just do this arithmetic correctly. We get 84 plus 216, which will give us exactly 300. So the probability is going to be 300 over 11 times 9 times 5. The 3 obviously can be canceled out with the 300. And we can cancel out another 5. That gives us 20 over 33, or answer choice C as our final answer. So that is the end of this problem, and it also means that is the end of this video. With that being said, hope to catch you in the next time. And if you have any questions, again, please drop them down in the comment section below. And don't forget that I have full notes in the description below as well. Thank you so much for watching, and I'll catch you next time.